Dr. Atchison here, and we are talking about Chapter 4, Recognizing Visual Options, and we've moved on to perceptual grouping. So perceptual grouping is another area that you typically have probably covered in intro, but again, we're going to talk about it in a little bit more depth, and this is the idea of the gestalts. Okay, so the classic gestalt principles of organization are referred to as laws, and in general, that group and figure is what the organism pays most attention to. And again, we're ignoring that background. So again, this is the idea that we've done figure to ground, and we've figured out what's the figure and what's the ground, and now we're ignoring the ground, and we're just trying to find out more about the figure. Is it one figure? Is it multiple figure? How do we group these things together? And these principles of perceptual grouping, these gestalts, were first done by Wertheimer and the other gestalt psychologists. And they created these experiments to try and figure out how people were grouping things. And what they did is they gave people arrays of things to look at, so different images of really simple elements, and they manipulated them in different ways to figure out how people were grouping things. There's a launchpad exercise that's going to really walk you through all of these: proximity, similarity, common motion, symmetry and parallelism, and good continuation. Good continuation, not as much, but it's still in there. So do that launchpad exercise. Again, these are those images that it's going to go through all of these. Those are the activities that are in that launchpad exercise that is, again, assigned for a grade. Good continuation is this. What do you see? When you look at A, do you see B, the idea that it's that teal line on that green line? Or do you see C, that you have two green rectangles and you have a teal rectangle on top? Because of good continuation, you see B. You're going to perceive it as B. That we have two images that one is on top of the other. This can also, and because of good continuation, when you look at D, you're going to be more likely to see it as E, that these aren't connected, that these are two separate things because they don't have good continuation. If you thought, because it's not on that same line, you're going to perceive those two separate things. You're not going to perceive it like F, that it's one image that is kind of angled, that has kind of a slide section in it. You're not going to perceive that. You're going to perceive E because of good continuation. This works also for curved images. So when you look at G, you're going to see that G is one image on top of another image, or you're going to say that H is one image on top of two images. So this works for both straight and curved edges. So when you look at both of these images, do you see a bunch of diamond-shaped fur and flowers, or do you see a cat and a plant behind a grate? When you look at B, do you see different kind of boxes in the sky, or do you see a building behind a tree? You see a building behind a tree. You see a cat and a plant behind a grate because of perceptual interpolation. You can see despite these occluded surfaces. And you can see edges that are invisible. So in both of these images, a lot of it blends together because we have white on white, and it's almost identical, especially in those eggs. It's really hard to kind of see sometimes where that egg hits the background. Yet, we see these edges, and we correctly perceive that those are eggs against a white background. And this is a tea set against a white background because of this perceptual interpolation. So there's two different operations that are happening in perceptual interpolation. More often than not, even if these objects are occluded, so even if the cat's behind the grate or the building's behind the tree, we're still able to see the cat and the building. despite the fact that large portions of them were occluded, especially in the building. Most of that building was occluded, but we could still see the building behind the tree. And this is done through two different mechanisms, one of which is finding edges, and the other is completing surfaces. So we do this, part of our perceptual interpolation can lead to illusory contours. And illusory contours are when we perceive that there are edges that aren't necessarily there. So the process of edge completion, where we're going to kind of make edges that aren't there, a hidden edge, is where we'll see these illusory contours, which are kind of these non-existent, but perceptually real to us images. We'll perceive them as there, even though they're not there. The other mechanism that's going on here, the other operation that's going on with perceptual interpolation, is surface completion. And this is where, again, that perception of a partially hidden surface will be seen as complete. And again, both of these, surface completion and edge completion, are involved in perceptual interpolation. So in edge completion, when you look at A and you look at B and you look at C and you look at D, do you see edges that aren't there? Can you identify the illusory contours in this illustration? So when you look at A, do you see an image on top of it? You don't see those black lines between those two circles, but you perceive it nonetheless as a white line on top of two black circles. The same thing with B. You're perceiving it as a curvy line on top of two black circles, even though it's not there. C is the famous illusory contour, where we're perceiving a triangle on top of three circles instead of just three Pac-Man shaped objects. We perceive this triangle even though it's technically not there. And that's even true of D. We don't look at D and say, oh, well, I think it's three Pac-Mans and three Vs. No, we say it's a triangle on top of a triangle. We see this other triangle there. We do edge completion. We complete those edges that aren't there. And this allows for these illusory contours. These illusory contours that you see right here. Sorry about those slide changes. In surface completion, we have here what we did was we took those similar images in A and B and we completed those circles. And that completely changes our perception. We no longer see that white bar on top of it. We more see it as there's two portholes through those circles in A and B, and we see this as those are now on top of the white lines. And in image C, we typically perceive this as a box on top of a circle. Again, we don't see it as an E, a box on top of a Pac-Man shape. We see it as D, two separate things. We complete these surfaces even though they're not there. We have perceptual interpolation where we see things that aren't there. We perceive things that aren't there. In the case of C, it could just as likely be F, but it won't be F, and we're not going to think it's F. It might be F, but we won't think it's F because remember that idea of simplicity. We're always going to say, oh, it's the simplest answer, and the simplest answer is D, partially because of surface completion. We're going to take those two principles and that's going to work together. These perceptual organization really came about from natural constraints. So you're going to watch a video that talks about the environment dictating our perception. And we see different kinds of perception based on the environments that we've had experience to. So these are mechanisms that are adaptations to the physical worlds that we are in. And this gives us an advantage. It allows us to survive if we can see important objects in our surroundings. It increases our survivings. And the fact that we are adaptable to our perceptual world is an evolutionary advantage. there are many cases when this perceptual organization is not going to do us a great job. And this is the case mostly with human-made perceptions. So things that are human-made, not nature-made. The case of magic tricks, perfect example. We're going to fool the perceptual system every single time with those human-made. All these illusions that I show you in class, those are human-made, and it will fool your perceptual system. The illusions in the natural world really aren't as prevalent as the human-made ones. The only caveat, one of the main caveats to that, is when an animal takes that perceptual mechanism and uses it to their advantage for their survival. So we say, okay, well, these animals' perceptual systems work this way. So if I camouflage myself, then they can't see me. The figure blends into the background rather than standing out from it. So in the case of A, that's a moth. In the case of B, that's a cephalopod. And neither one of those can you see very well because, again, that figure blends into the background. They took that animal adapted using our perceptual system. Those principles that organize our perceptual system allow for camouflage to work. And many species use it to avoid predators. Human animals use it as well. We clearly, even in a man-made context, will do things to camouflage as well. So again, camouflage is operating, saying, okay, well, we know what these perceptual constraints are. Let's work with them as a way to not be seen when we don't want to be seen. So that ends lecture 3 about perceptual grouping. I'll see you in lecture 4.